Alright, you guys, so we're going to do 6.1, which is algebraic expressions. That's our standard 7th grade expressions and equations, number 1. And your objective is to be able to add, subtract, factor, and multiply algebraic expressions with at least an 80% accuracy given your independent practice. So, 2 vocabulary words that we need to know before we get to our lesson. So, algebraic expression. It's basically a math phrase, just like you have phrases in English that has at least one variable. Remember, variables are the letters that we utilize from the alphabet in math to describe a number that is unknown until you're like gonna play the little spider, you're gonna figure out the number. So like X, Y, M, any letter from the alphabet can be used as a variable. We usually see the X and the Y, but any letter is fair game. One of the things that you have to remember is that if you see something like this, that is not an expression. That is an equation. The equal sign makes it an equation. So make sure that you know the difference. Expression does not have an equal sign. Equations do. So I'm going to erase that so that you don't get confused. So again, it's a math phrase. That one will be like a math sentence in a way because it has an equal sign. And then a factor, going back to 6th grade, remember factors are numbers that you multiply by each other to get a product. So think about a factory. Factory, you make things. So when you multiply, you're making a number. So product is what you get from factories, right? So then you need those factors to be able to get to 15. So in this case, 3 and 5 are factors of 15. Another pair of factors of 15 will be 1 and 15. So this will be factors, and then this right here is going to be my product, okay? So here we go. We're going to start with adding expressions. So before we get to anything, one of the important things that you have to remember is that you have to combine like terms. And going back to that, terms are this. So this will be one term, this another term, and they're divided by an operation sign. So for instance, if you have 3x plus 2 minus 5 divided by 2d or something like that. And if I add letters here, that will be one term, 2 terms, 3 terms, 4 terms, because they are separated by an operation sign. Okay? So in this case, this one has 2 terms. So we have to remember that. I use my bananas and my apples because I'm saying, remember when you combine line terms, you have to have apples with apples and bananas with bananas. They cannot be combined. Like you put them in separate baskets. You're not going to get like papples, right? Or bananas. I don't know. Okay. So that's the first thing we want to do. And for us to do that is for them to be like terms, they have to have the same variable if they have one. So in this case, this and this are like terms. You cannot combine those two because this is a constant that's just 0.5, that's half, but this is 3x. So that means 3 times an unknown number that we don't know yet. So we're going to combine those together, and then we're going to combine these two together because they're constants. You already know the value of those. You don't have to figure anything out for those. So I'm going to combine those two. So I'm going to say 3x. And then bring down my plus, and then 7x. And then I'm going to say plus, because there's a plus in front of that, plus 1/2, plus, right? And then you have a negative, negative 4.5. So when I do that, 3x plus 7x is like saying 3 bananas plus 7 bananas is 10 bananas. So that will be 10x, okay? And then right here, I'm going to combine these two right here. So going back to adding integers, different signs, remember we have to subtract the absolute values. So that will be half plus negative 4.5. I'm going to take the absolute value of those two. So the absolute value of this is 4.5, and the absolute value of this is 1/2. And I'm going to subtract those two. Remember, I start from with the biggest one, so that we'll have that, and that's going to give me 4. Now, because I have more negatives, then it's going to be a negative 4. So then I can say plus negative 4, which essentially is going to be just 10x minus 4. And that is my answer. So that will be your final answer. You cannot do anything. So you're basically just simplifying, adding the expression, but you don't know that value yet until you're given the value of x. Okay? And let me kind of just go back to this right here in case you forgot. Like if you have 2 negatives and you have 3 positives. This one is basically saying negative 2 plus 3, right? So then again, you have different signs. So you subtract because you're doing 0 pairs. Remember, they're going to go dance, dance, and then that one's lonely. So you end up with a 1. And it's a positive because you have more of those. So that's how that works. Let me give you one to practice. Okay, so go ahead and do that one for me. Okay, now we're moving to subtracting expressions. Same idea, we're going to combine like terms. So again, whenever they have the same variable raised to the same power, those are like terms. So I can add those two together and I can do those two together. I'm going to rearrange them. So then I have negative 0.25x and then minus, don't forget the minus outside parentheses, minus 1.5x. And then I have negative 3 and then minus a positive 1.4. So I'm just going to say 1.4. You can add the plus sign here, but you don't need to. But if you want to, you can. It might just look a little weird there. Okay, so then I'm going to combine like terms. So then right here I have negative 0.25 minus 1.5. Remember, we can rewrite this as an addition of its opposite. So I can do keep, change, and then opposite. The opposite of 1.5 is negative 1.5x. So when I add those two together, same sign, I add absolute values. So that's going to give me 1.75x, so and 7500x. And they're both negatives, remember? So we're going to keep using the common sign. And then right here, I have negative 3 minus 1.4. Again, same idea here. I can rewrite as negative 3 plus a negative 1.4. So it's going to, same sign. So I add absolute values. So that's 4.4, and I keep the common sign, so that will be my answer for that one right there. Okay, so let me give you one to do. Okay, so go ahead and do that one for me. So now we're going to go to distributive property. So the distributive property is you are distributing this number outside of the parentheses. So that's the first thing you want to do. You want to distribute this to each one of the terms inside. Remember, this one term and this another term. So you have to distribute that. And you have to always keep in mind the sign in between those terms. So 0.2 times 3b. So I'm going to multiply those two together. And that's going to give me 0.6b. Don't forget the b, because if you do, you're going to get it wrong. And then I'm going to bring them. So then I'm going to take this. I'm going to say 0.2 or 2/10 times that. And that's going to give me 30 hundredths. Don't forget the c. Okay, and there's a minus in there, so I'm going to bring that down. And I'm going to add plus 6c. Now, in this case, again, I'm going to combine like terms. And I don't have any more b's, but I do have c's right here. So when I add those two, so I'm going to bring this one down. So I have 0.6b. I should have chosen another letter so it doesn't look like a b. Okay, and then I have negative 30 hundredths plus 6. So remember, I'm going to, because they have different signs, so I'm going to subtract the absolute value. So basically, I'm doing 6 minus 0.30, and remember, I have to line up my decimals, so do not forget that, otherwise you're going to get it wrong. So then that is going to give me 5.7, and because I have more positive, it's going to be a plus. So then that is my final answer for that one right there. Okay, let me give you one to do. Okay, so go ahead and do that one. So remember, you have to distribute the 5 to each of the terms first, and then combine like terms. Last one, we're going to factor. So remember, we're trying to figure out what numbers multiplied by each other give me this. So the first thing I'm going to do is I'm going to look at my coefficient, which is the number in front of the variable, and I'm going to look at the constant. And I'm going to think of a factor that works for both of them. So in this case, I can do 1 times 4 and then 2 times 2. In this case, I can do 1 times 16, 2 times 8, and 4 times 4. The greatest one of them is 4, so I'm going to pull out a 4. So in this case, I'm doing 4 times 1, and this is 4 times 4. So I'm going to pull out a 4, and I'm going to take it out right here. So it's going to be your greatest common factor. And then you're going to do your parentheses. So then right here, you're saying 4 times what gives me 4x? So it's 4x, right? 4 times x gives me 4x. Good. And I'm going to bring down my plus sign. And I'm going to say 4 times what gives me 16? 4 times what gives me 16? That's 4. So 4 times 4 gives me 16. So if you can see that right here, you're taking the 4, and now you're taking this one's right here, and they're going to go inside, but with the variable, right? Now, essentially, there's a 1 in front of the x, but like in English, we don't say I have a 1 pencil. You just say I have a pencil. That means 1. That's what we do with the variables. If there's only 1, we don't write the 1 in front of it. Okay? So let me give you one to do. Go ahead and do that one for me. And this is your number 3, and this is going to be your number 4. All right, remember, math is magical. You're amazingly brilliant. You got this. God bless you. Bye-bye.